Can anyone tell me what you see on this picture?
Is it a ship or something like this?
Yes, exactly. It's a ship, and it is, you can notice, any modern ship is divided into separate, I would say, isolated compartments, right? These bulkheads divide the ship into completely dedicated, separate departments, compartments, isolated parts. Why they are needed? When, as I mentioned, let's say we have a ship and 4 compartments. When one of them is flooded, the the ship remains floating. It's not sink immediately after the first hole in the body, right? It allows additional safety. Yeah, similar situation can be applied to our Terraform configuration. Let's say we want to make some dangerous change, right? Let's say we want to apply something, and even after we run Terraform plan, we're not sure whether it will be okay or not, right? Whether something will work, whether we will not break our state file or something like that, right? So, and what we do today is implement very similar strategy of like separate compartments or layers and isolate parts of our infrastructure one from another. Another good example, let's say we'll have a networking team who is responsible for manage cloud network. And let's say DevOps team who is responsible for managing instances, right? We don't want to step on each other's toes. We want networking team to provide us a VPC and simply consume it and let's say deploy instances to our VPC, right? This means we need to somehow like again separate our infrastructure, separate our code. And let me show you today. I will show you how this can be done, how this can be improved, and how this level of scalability can be achieved. Okay, and without further ado, let's start. Let me make sure that we have our latest commits. I will call these levels. Let's say we'll have separate levels of our infrastructure, like a layered cake, I would say. So there will be multiple folders. Let's say level 1 and level 2. First, we'll move the provider configuration. Provider configuration will be almost identical. So let's say our level 1 will have these. And the only difference is, no, let me show this later. And also probably AWS VPC, route table, yeah. This main.tf is solely dedicated to our VPC. We can move it there as well. Main provider, what else we would need? AMI we don't need, instance we don't need, outputs we don't need it yet, variables. Okay, let's copy paste our variables. And TFVars. And also I will remove everything that does not need it for our VPC. I will comment it out first. And if everything works, I will remove them completely. Now what I do next? And also, since this will be a dedicated state, separate state, they should not share the TF state file. Let's call it level 1.tf state. And obviously some errors in the code has not been declared. Let's check. Variables, yeah, probably we need to return this and this. Availability zones count in the, yeah, and we also need our availability zones as well. And you see only 17 resources created, and we're creating right now within this level 1 folder only resources associated to our VPC, to our network. Let's say we'll have a shared network and we'll create multiple resources within one network. And yeah, it was kind of really quick. I rushed into showing and demonstrating this, and I know this concept is a little like complicated. Yeah. So can you guys tell me if it's clear enough, or do you need any additional explanation here? I need you to somehow like acknowledge that the reason why we're doing this is clear.
Well, actually, I didn't get it.
Mm-hmm.
Like, are we creating a separate VPC or?
There is a concept of Terraform state. You remember this, right?
Yes.
TF state file. And Terraform state is our boundary, is our borders within Terraform is looking for resources. And what we are doing now is creating two different state files. So we can run Terraform apply and limit our blast radius only to within like small subset of our resources.
Okay.
Does it make more sense now?
Yes.
Yeah. So we have this level 1, right? Now we'll have level 2, right? And we move within a minute from now. We will move all our EC2 instances to level 2. This means whenever we have a change in our EC2 instances, we don't have to touch anything that's related to level 1, and we basically creating additional safety measure. We are reducing the chances of us accidentally changing something in the VPC because we're simply not applying it, and it is simply stored in a different state.
Okay, perfect. Thank you.
Okay, very good, guys. Anyone of you except Mohammed, do you have any questions? Yeah, let's make sure everyone on board. Let's make sure everyone understand what we're doing.
Yeah, so I have a question. Like, so with us separating the TF state like files, so if like a user or developer on level 2, for example, runs Terraform destroy, so he will destroy only the instances. I will not like destroy the whole
Yes.
VPC.
Yes.
So that's a benefit as well, isn't that?
Yes, that's totally right. Exactly. Same here. We are protecting ourselves from these like huge blast outages. Let me clean up it real quick. Okay, very good. Now what I will do is create, as I mentioned, separate level 2 state for our instance. So we will move instance, we will move provider, we will move, we will need our data source, we will move our TFVARs and variables, user data as well, outputs, we don't need it yet. We will declare them separately. Okay, and we will remove these variables, and I will also test this out, make sure that they are indeed not required. So we step out to a completely separate folder and run Terraform init and Terraform plan. Okay, cool. There is an error, but I was expecting this. But can you guys tell me why it is? What we did wrong? Do you have any ideas? Yeah, Padya, move forward.
We have referenced like the VPC, the main VPC, but it's not like created in this file. It's created in a completely
Yes.
different folder. And the TF state doesn't know about this resource at all.
Yes, that is totally right. Let's get back to level 1 and use Terraform state commands that we discovered during our previous session to discover what's the idea of our VPC. Okay. So this one. So for now, I will just that's just a temporary measure, just to make sure, just to validate this assumption. So instead of AWS VPC main ID, I will just hard code our VPC ID and make sure that the error is gone. Yeah, and it is asking us to do the same with subnet, and it also wants VPC CIDR. Okay, but before we continue solving these issues, I bet you already know that just hard coding these IDs is not the right way, right? Because if we, for example, destroy or change or recreate level 1, this ID will change. And we somehow need to obtain this dynamically, right? So what we can do is similar way we referenced distinct resource, we can ask Terraform to connect to a separate state file and extract the required information. So how we do this? So first, we will need to declare it as an output in our original state. And in our level 2, we need to create additional data source called Terraform emote state. Hold on a second, just checking some additional things. And yeah, I found it. And in the body of this data source, we need to specify that it should should search for these for this remote state in S3 in this bucket and in this file. Essentially, very similar to what we have here in our provider configuration of the original level 1. And in our instance.tf, we can tell it data, Terraform remote state level 1, outputs, and the output that we have declared. And with VPC, and let's replace it over here as well. So we will need to repeat the similar things for basically everything that's declared here. This will be our subnets, public and private. So let's also declare them as output again. And same for the private subnets. And by the same token, we did this for VPC. We need to replace our public subnet with data source. Like this, and private will be replaced with private. It also told us something regarding VPC CIDR. It will be generally like good idea, instead of using variables, to also expose it from our level 1. Because if we update it, it should be updated respectfully, like down the road. And let's test it out. Hope this will work now. Yes.
So now level 2 is dependent on level 1. How
Yes.
can we make sure that level 2 can't get any problems if we touch level 1? Like, what if we destroy level 1?
Yeah, you will not be able to destroy level 1 because you cannot delete a VPC that has a resource in it.
Okay.
And obviously, it is not possible to completely like separate and isolate them. But for example, if you destroy something in level 2, level 1 will not be touched, right? So you can see it as a parent and child relationship, right? Bigger the level, higher the level, more dependencies it has, but more like safe and independent it is to update it. Of course, even if we have these, it doesn't mean that we should be negligent. We still should be extremely careful, and even more careful when we deploy like lower levels, like level 1 or whatnot.
Thank you.
And for these changes to take effect, we need to go to level 1 and run Terraform apply. So these outputs are written into the remote state. Yes, we have declared our outputs. And let's run Terraform apply one more time here. But, okay, something is wrong here. Private subnet IDs. Let me make sure I named it correctly. Oh, correctly. Public subnet IDs. I mistyped that. Obviously, it should be subnet, not subend. And Terraform apply one more time. Let's hit yes. Okay, very cool. So now, as I mentioned, as we described, if we run Terraform destroy, it will only suggest us to destroy only these 4 resources that are related to our VPC and that are related to our instance. I'm sorry, of course. And obviously, it will not touch anything except this. It will not touch our VPC. We are still completely safe, and we don't have to care about whether entire architecture will be dropped, will be destroyed. Okay. While it is destroying, I will show you one more thing. So, as you remember, we have this concept of remote state and S3 bucket that stores the state file. So what we can do previously, last time we created this bucket and this DynamoDB table manually, right? But we can move even further and have these remote state bucket and remote state DynamoDB table be automated through Terraform as well. But before I do so, I will quickly change this because it should be level 2. So I will create new folder and call it level 0. And this will contain only a couple of resources. This will be our S3 bucket that we already created. We already created it. This means we'll need to run Terraform import command to make it work. And DynamoDB table that we had. Let's go to level 0. First run Terraform init and Terraform plan. And it is suggesting us to create this AWS S3 bucket. Why so? obviously, because we don't have yet information about buckets that already exist in our state file. And very similar to what we did last Thursday, we need to import these resources. Terraform import AWS S3 bucket Terraform remote state and our bucket name. I will take it from here. And by the same token, we will do with our DynamoDB table. Non-existing remote object. Okay, interesting. Yeah, let's get back to AWS and check the name of our DynamoDB table. Maybe we need to adjust it. 1 second. Tables, Terraform remote state lock. Let's get back here and make sure, yeah, it was remote state instead of Terraform remote state lock. And how do we check that Terraform import is successful? The resources we imported should remain untouched. What we have defined in the code should correspond one-to-one, exactly match to what we have imported to what already exists. So if I press enter and have 0 changes, this means import was done correctly. Otherwise, this means I made some mistake. Let's find out. Yeah, very good. It says no changes, infrastructure matches the configuration. And what we also have is, hold on a second. But we can see that there is a local terraform.tf state. What do you think we should do with this tf state file? Where should we put it? Where should we store it? Keep in mind, it's a tricky question. Any ideas? Okay, so since we are trying to create, let me actually destroy level 1 and I will even demonstrate it to you. Okay, very cool. It is destroyed. Let's go to level 0. While we were waiting, I have also configured remote backend for our level 0 as well. And let's migrate state by running Terraform init one more time. Yes. And now let's run Terraform destroy and try to recreate. Hit yes. Okay, very cool. First sign that we have, it says error releasing state lock. And the bucket we're trying to delete is not empty. And that resource not found. Isn't look suspicious to you? What you think is happening here? Why we were not able to destroy, and why we were not able to release the state lock? Anyone?
The TF state file of level 0 is stored in the same bucket that was created from the same level. Kind of
Yes.
feel like a loopy kind of way, like
Totally right. That is also called chicken and egg problem. So we have this Terraform remote state. So Terraform will try to go to this bucket and will try to go to this table, but at the same time, it creates it. And in order for it to be created, it's trying to go to the bucket that it should create before it's even applied, right? And this infinite loop is happening. And this means we, for sure, are not able to store our our state remotely in the same bucket we're trying to manage using this level 0, right? So it should go to local backend probably. Let's reapply it back with local. And yeah, let me just remove the Terraform folder. It should work perfectly. So very simple trick. Anytime you have some unclear errors when you run Terraform init, you can always remove .terraform folder, and it will never hurt. Like 99%, it is like, okay, it's a regular debug step. When something you don't understand when you run Terraform init, just feel free to remove .terraform folder. And it will like re-download everything and reinitialize everything like completely from scratch. Okay, and let's run Terraform apply. And probably we need to run Terraform import one more time. No. We only need to import our bucket. Table should be recreated.
The table had to be recreated because like it was destroyed by
because
our previous.
we were able to destroy the table because table can be destroyed without any conditions. However, we failed during destruction of our bucket because the bucket, in order to be deleted in AWS, should not be empty. Should be empty. We
Should be
cannot
empty.
destroy a bucket that's not empty. That's why it failed, saying unable to destroy, because we had these state files over there, right? But
Yeah.
it destroyed DynamoDB table. After that, it tried to release the log file, tried to find this table that it previously destroyed, and say it not found, right? And now we recreated this table back. And to make sure everything still works fine, let's run Terraform plan. It will be enough. To make sure it can connect and lock this remote state. Yeah, all good. So what then we can do with this state file? Because we still need to maintain the state. We don't want any colleague that of us to attempt to recreate or to run Terraform import every time, right? Do you have any other ideas? If not in S3, where else can we store and share this TF state? Yes?
GitLab, maybe.
Yes, exactly. In GitHub, we can simply make an exception and commit terraform.tf state as well as like other files that we have. And whoever will be working with us will clone the repository and receive the copy of TF state locally. That's how it can also be done. That's how it can also be managed. So level 0 is committed to Git. Level 1, 2, and so on will be managed by S3 and Dynamo that's created by level 0. Does it make sense?
Yes.
Yes. Can we make like a separate S3 bucket for it?
And how do we manage this S3 bucket?
Yes, yes. It could be the money.
Yeah. So now the only thing that we need to do is add everything. I will also, since it's in git ignore, I will try explicitly add zero. Yeah, it says it's ignored, but I will anyways add it. Just only this file. Now, as usual, I'll just push, create a pull request. Okay, looks almost good. So let me fix myself, right? I'll review it for myself. And it could be a good habit if you also, when you create a pull request, does not matter if it's Terraform or any other code that you're working on, always go to files changed, right? To the summary of pull request and check what exactly happening. So I discovered that I need trailing new line at the end of level 1 outputs TF. What else I need to do? Level 2 data.tf. Also Terraform TF vars and variables TF. It's not a good practice to leave commented out block codes of blocks of code, right? And the rest is fine. Actually, no. Let's also make sure our indentations and code style is right? Never forget to run Terraform FMT, and you can add minus recursive flag, so it goes to each nested folder and fixes there as well. By default, it goes only on the same level, so you will need to add recursive. Regarding Terraform Destroy, we have multiple states now, and when you're not studying, it will not be enough to run Terraform Destroy once. Always make sure you run Terraform Destroy in level 2, level 1, but you don't have to run Terraform Destroy and recreate resources in level 0. An S3 bucket and the DynamoDB table will not cost you anything, and almost anything, and definitely fall under free tier. And it will be easier for you not having to push and update your Terraform state, because Terraform state will be always unique on each apply. So just apply it once, commit Terraform state, and keep it in level 1, in level 0. But make sure that you never forget to delete level 1 and level 2, right? Because now you have multiple state files to manage. Very important. I don't want you to go bankrupt. Okay, I will review one more time. Everything looks legit, and now I can create it. Okay, very cool. Let me update Trello so I don't forget right away. Is your data late approach in Terraform? And that's it for today. The task is on the Trello board. The recording will be available within several hours. And if you don't have any questions, we can finish for today.
Thank you for today.
Thank you.
Thank you.
Thank you. Bye.